All right, welcome to this video where we're going to take a look at a set of data and try to figure out is it normally distributed or not. I'm going to run two tests in order to figure out if it is. Those two tests are they do a really good job of trying to figure it out. Another way that we could do it is by looking at a data set as a histogram, and if it follows that really nice bell curve, it tells us that it's probably normally distributed. There's not a bunch of points off to one side that are kind of skewing data and such, but we can also run some data tests which don't deal with a histogram at all. So, like I said, we're going to run two tests. Number one, the first test that we're going to do is the mean in the middle. It's the first thing that we got to look at, and we want to try to figure that out. How we're going to do that is look at is half of the data less than the mean or about half above the mean, vice versa. And so we're going to take a look at that based on a data set. Now, I'm going to say this a couple times here. This calculation is going to be like roughly the same, like roughly there. So if it's not exactly 50%, that's okay. I always give a 5% buffer on either side, so like 45 to 55%, which I would totally be acceptable with as well, based on the size of the data sets that we're using. Here's the data set that I'm going to use. I got a bunch of numbers. These are from Phil Mickelson's golf scores on the PGA Tour back in, I think, 2019 is when I took them from. And so we want to see, is this group of data normally distributed? I've made a histogram with this before, and it looks like it's a pretty good bell curve. So we're going to assume that it is on that, but let's run these two tests to see if, in fact, it is. So first of all, is the mean in the middle? Count the data points that are below or above the mean. I'm going to use below for this one here. So the mean is 71.03. That means that all of these data sets, 71 and lower, are going to be part of that. So count them up. There's 30 of them out of the 60 in total. So 30 out of 60 happens to be exactly 50%. Woohoo! That's always good. It's always fun to see that. And so therefore it fits between that 5% buffer, 45 to 55% around the mean, and check mark, yes. Test number one is good. But that's only test number one. So let's take a look at test number two. Test number two is going to look at the normal chart here and see, are we getting about 68% of our data in between those first two standard deviations? Okay, so that yellow part there that you see, can about 68% of the data fit in between there? To do this test, we're going to need to know the mean, and we're going to have to know the standard deviation. And when we do it, again, like I said, the calculation will rarely be exact. And so again, we're going to use a 5% buffer as acceptable on either side of that 68%, which means 63 to 73%. All right, let's go back to Phil Mickelson's scores here. And let's count up the data points that are within one standard deviation of the mean. Again, like I said, we need to know our mean and our standard deviation. So there they are. Let's subtract, okay, to figure out what our low end is going to be. Okay, so that's going to be our low end at 67.24. So really in this data set, that means 68 and higher. And then our upper end, okay, the top of that first standard deviation is 74.82. So we're adding one standard deviation. And so that includes this whole group of data. Okay, so all these data points would fit within that. All right, count them up. There's 40 of them out of the 60 in total, which means that 66.6 repeated percent are going to fit within those two standard deviations, one below, one above the mean. And this, in fact, fits within our 5% buffer. Okay, so it's very close to 68%. So we're going to deem it as acceptable. So therefore, yes, we get a second check mark. Both tests have passed, and both have to. If one doesn't and one does, we still throw it out. They both have to pass. And so because of that, this data, we are going to say it looks like it is normally distributed, okay, based on the two tests that we've done. And it's important to show the results of those two tests as well. I hope this has helped you. Thank you for watching. Have a wonderful rest of the day.